Hi, my name's Andy Ebbs. I'm a solution consultant at OpenText, and I specialize in high availability and migration. Today, I'm going to demonstrate how to migrate from a VMware ESX environment to a virtual machine running in Exoscale Cloud. I'm going to be using Carbonite Migrate. My previous video demonstrated how to actually install the agent, the Carbonite Migrate agent, on to a new virtual machine that I created in the Exoscale Cloud and configured it and opened some firewalls and so on. So if you're looking to understand how that works, you maybe want to check out my list of videos. So I'm starting by going to the exoscale.com website. I'm going to log in and just got my credentials there, so I'll just open up. And you can see this is the machine I created in my previous video. It's a Ubuntu virtual machine. I've already installed the agent and everything on it, and configure the firewalls and security groups and things like that as well. So it's all ready to go. This is going to be my target server. That's where I want to end up, the destination environment. But we're also going to be using a source machine, which is running in my fairly small VMware ESX environment. That's this machine, Ubuntu ESX source. I've used this in other demos as well, so you might have seen it before. It's just basically a fresh install of Ubuntu. It could be running any application. It could be running MySQL or Oracle. It could be running a website or whatever you've got running on that server. We don't really care. We'll replicate live open files, live open databases while the users are working on it, and there's no downtime while we're synchronizing the data. It's just a few minutes at the end that you'll see in today's demo where we'll shut down the old environment, start the new one up. So the first thing I'm going to go to is I've got actually a PowerPoint slide just to maybe bring up so you can see the background on it. So we're going to have a source machine, which is going to be, I don't know if you can get my mouse here, it's not showing on my screen, but you've got the source machine on the left-hand side, which is going to be the production server running in ESX at the moment. And then we're going to go to the target machine, the scale target machine that we're going to be replicating to. So the first thing to do is go to a command line. So I have here, I'm using just PowerShell command line just to get an SSH section to the source and the target. So this is my source server, Ubuntu ESX source, the one I just showed you in my ESX host. I wanted to quickly run through the configuration of that machine. You can see that it's a 2004 Ubuntu machine. It's actually Service Pack 6. And at the bottom, I've just shown the kernel that it's running, because there will be probably a warning message as we look through creating the job, just saying that they're not quite the same. So this one's using number 190, and my Exoscale machine is using the same generic version, but it's using 189. So we'll flag that up later on. Not to worry, it'll still work. Afterwards, the source machine configuration will overwrite the target machine configuration. So when we log into this machine in Exoscale later on, it will be using 190 because at the moment it's 189, but we're going to be moving this one over. Also, I'll just create a file just to show it's a live server at the moment. So if we maybe touch a file, and we call it demo file 1, should be able to see that if we look at the list of files here. That is just demo file 1. So on the target machine, I don't think there's much there. It's probably just the drivers. You can see the installation files that you'd have seen me create in the previous demo. When we do the failover, that's going to be overwritten. So this probably won't be there anymore. It will just have that. It'll have the same list of files that you can see on this source machine. So now that I've got the agent installed on the source and target, first thing to do is go to the Carbonite replication console. I've already added these two machines in. So we've got two servers, Ubuntu ESX source, which is the machine that I've got running in my ESX environment. That's going to be the source machine. And then I've got my Exoscale target machine, again, Ubuntu 1. So that's the one we're going to be replicating to. I've got a license key on the source machine. You only license the source, you don't license the target. It won't work, in fact, if you do. I'll right-click on that machine. I'm going to choose that I want to migrate it. I choose the workflow that I want to use, which is full server migration. I confirm which volumes or mount points I want to actually migrate. And you can see I can customize it. So if there's things I didn't want, I could exclude those from the replication. So if I went to a home and I didn't want my home directory, for instance, I could create an exclude rule and add a rule to exclude that. But I'm not going to do that in this case. So I'll just use the defaults. Then I'm going to choose my target machine. So it's offering two choices here. I've got another Proxmox host somewhere that I could be replicating to. I'm going to go to Exoscale. Then I get a few options, and they are options. I could just click next here and it would be all done, but I do want to change a couple of things. I wanted to keep the target machine's IP address so I can still connect to the machine by SSH once I fail over. Sometimes you need to be able to fail over the IP address because you've got applications that are using specific IPs and so on, but you will need to consider that when you put your network together. So I'm going to retain the target IP address that Exoscale allocated to that virtual machine. So I know it's all good, the network is good, all the routing and so on is all going to work for me. So that's all set up. The other thing that I'd probably want to change is just turn compression on, just reduce the amount of time it takes to synchronize the data because we're going to send less data over the network. Our compression's fairly effective at compressing quite a wide range of different data types, and it'll probably halve or less the amount of data that gets sent. So I'll click next. It will now validate those settings. We've got a few warnings there, none of which I'm too concerned about. The kernel version, I've already pointed out, they are slightly different, but it's not going to affect this job. We'll end up with the latest kernel because that's what's running on my source machine. The volumes, it's basically saying that the size between the source and target aren't the same. That's fine. We're going to be replicating file system, so you could have a source machine that had a 100 gig disk. The target machine could have a terabyte disk. After failover, it'd still be a terabyte disk, but it would have that 100 gig of data that have been copied over. And again, it's just warning us again that there's a difference in size. It would only be a problem if we were going from a big disk to a small disk. You just need to make sure you've got enough space for the data that we're going to be replicating. But everything else checks out, same number of processors, same amount of memory. They could be different. It would just give us warnings just because your applications might be sensitive to that sort of thing. So I'm going to click finish, and that should create the job. So should that pop up here? So Ubuntu ESX source to Ubuntu ESX target, so Exoscale target, and you can see the source and the target machine. It's mirrored required, which means it's basically going to synchronize the data in the background while the server remains live. Just have to give it a few seconds for this to start up. It's now mirroring, done 3%, and we'll get some stats at the bottom here in a second once it's sent a bit of data over. There we go. So it's about 8 gig to be sent. That's going to take it a couple of minutes, I would imagine, because we're replicating from my host, which is running in my home lab, through a standard BT fiber to cabinet connection. I'll be lucky to get 10 meg up, so it's going to take it a little while to send that data, but it's going up quite quickly there. But you can see also the compression. So far, it's sent about a gig of data, but it's been able to compress that down quite significantly. I'm quite impressed by that. I think it's actually going to be a bit more than that, but it must be data that can be quite easily compressed at the moment. But you'll see this change as we go through. I'll try and point it out before we fail over. So while that's doing that, I just want to reaffirm that I have my source machine, I've got my target, they're both live. I'm going to create another file. I'll just give it a slightly different name to the last one. If we look at the target, though, you'll see that file's not appearing here, even though we created a connection. And there is a reason for that. It's because where we actually put that data. At the moment, it's stored in a hidden directory. We can actually look in that directory. If I look on my on this machine, so I'm going to change into that directory, which is root, and then it will be .dt staging. And in that directory, well, might as well change into that one. I probably need to do this as sudo because of permissions and so on. It's typing. What have I done wrong here? cd. Okay, Linux isn't my first language, and I was trying to show you something here that's probably confusing everything. So I'm just going to change up to being root instead. and then I'm just going to show you that directory. So if we look in CD, it is here somewhere. In fact, the easiest way to do that is to change to root, and if I just show you everything that's actually in that root directory, it will show that data a bit more clearly. This folder here I'm going to show you, this was DT staging. So if I change into that DT staging folder now, we'll see that there's a home directory, and if I change into home and then Andy, we can see demo file 2 there. Now you might notice demo file 1's not there, and the reason for that is we're mirroring at one level, which is the synchronization phase, and you see it's still at 24% there, and it hasn't actually got to the other files in that directory. But when we created this file, that's a new change, and we prioritize new data over mirroring. So we're doing these two things in parallel. Mirroring to give a baseline copy of the data, and replication is the deltas, the real-time change. So if I, again, go back to this source machine and I create another file, we'll call it 3, you should see that one appear on this target machine pretty instantly. And if we give it a little bit longer for this data to synchronize across, so I'm just going to probably pause the video while it just goes up a little bit, you'll be able to see all those other files that we were expecting to see, all these ones from this machine, all these different drivers and things like that, they will be copied into that directory. And I can keep refreshing it every so often, but I've no control over which files it mirrors in which order. It just will do that by the time it gets to 100%. And in fact, it's slowed down quite a bit. I presume the compression is probably showing a bit now. It's done 2.3 gig, still got 6.9 gig. So we're probably looking at this taking 5 minutes so far. It's probably going to take about 15 minutes, mainly because of my slow connection between my home and the machine that's up in the cloud. Okay, so it's finally finished mirroring. It's taken a little bit longer than I anticipated. Probably should have done a quick test before I did the actual replication, but I am going to blame the speed of the connection. I'll maybe just I'll prove what's going wrong there, why it took so long. If I run the speed test, just showing you my home Wi-Fi or network, we're getting about, this is the download speed, so that doesn't really make, doesn't really make much difference, but it's the upload speed. So I'm taking the data from a ESX host in my home, uploading it over a 10 megabit link, and I get about 9.34 megabits per second. And then if I have a look at a table I have here, which allows me to get some rough estimates, and these are always guesstimates anyway, you can see that if you've got maybe 9.2 gig of data and a 10 meg link, it's going to take about 2 hours. Now, because the data gets compressed as we send it, it's been a little bit quicker than that. So there will still be an overhead for lost packets. And I'm working in a home environment, so I've got the kids using the Wi-Fi and things like that as well. And the neighbors all sharing the same contention ratio. It actually sent about 3.3 gig. And if we have a look at the actual bandwidth that was actually used again, so if we change this to 3.3, so it reduced it down to about a third of the size. You can see that's why it was slightly quicker, 0.73 hours. So what's that, about 45 minutes? I think it probably took closer to an hour, maybe even an hour and a half, just because there's other stuff on the network. There's also a latency of sending packets and waiting for responses and things like that. So you're never going to get the full 10 meg. But what I really need to emphasize here is this might have taken an hour, it might have taken a day, you might be sending terabytes of data, and it could be taking a week or two. But while you're doing that, with Carbonite Migrate, the users remain connected and continue working. So they've still continued working. These connections are still up between the source and the target. If I create another file here, demo file 4 now we're up to. If we look on the target in that staging folder that I was talking about, So this is the root.dt staging home and the directories where we're temporarily putting these files. If I just look at those files now, you'll see that we've got demo file 1, 2, 3, and 4. And the users are still live on this production server, so you can continue working up until this point. So you can install and configure and create the job and synchronize all the data, regardless of whether it being terabytes and terabytes of data, without interrupting the users. And it's only now that we've got the data in sync and we're ready to actually do the cutover that we're going to do that. So just before we do the cutover, I'll quickly show you the source and target environment again. So you can see my source machine is live, running in my ESX host, and the Exoscale machine is also running. It's live as well. When we do the failover, what's going to happen is this source machine is going to shut down. That will mean that if there's anything in memory, it'll get written to disk, and we won't lose any data. And then the target machine is going to get rebooted, and the data from that DT staging directory, that hidden directory, will replace the plain operating system that's on that target. The machine will get rebooted, and we'll have a failover. Hopefully, that's going to take less than 5 minutes. It's usually just a couple of minutes in Linux. So let's do that now. So again, I'm going to go to the Carbonite replication console. We're going to choose the job. We're going to right-click on it. We're going to choose to failover and do a live failover. And this is the downtime. So you can see on my machine, it's about 10 to 9. I would expect that will take about 2 minutes to fail over. You can see it's already doing some stuff. It's saying target data not available, and that's because the target machine is being rebooted now. It's happening that quickly in the background that I can't see my source machine has gone offline. We've shut that down automatically. The Exoscale machine is staying running, but I'll just give it a minute just to confirm that the machine is rebooted. But we should see my connections here have been closed. So this was the connection to my Ubuntu machine in Exoscale, and my ESX source machine has been shut down as well. If we just give it a second here, I'm going to try and connect again to it. So I'm going to connect to the IP address of the machine that's running in Exoscale. I won't be able to connect with Ubuntu because Ubuntu doesn't exist as a user on the source machine. So I'm going to just quickly change that to the user that I have on the source, which is Andy. And it's telling me that I've already used this key and it's not going to let me connect to it with that. So I'm just going to pause the video while I quickly go and remove the file from the fingerprint, just to say that I want to connect to that machine, because it's basically, it's a security thing in SSH to make sure that the connection is safe. So I'm just going to pause things. I'll just delete that key and then we'll come back into this in 1 second. Okay, so I've made a change to the known host file, and I'm hoping that when I click on this and try again, it'll now just say that, so basically I've just removed the file, the entry for this IP address in the known host file, because I know it's there, but it's locked down because of the way I've got the security set at the moment. So I've just deleted that record. Now it asks, do you want to validate? And I'm saying yes, and now I can connect to it using the password for Andy on the source machine. And we're into it. So it still thinks it's Ubuntu ESX source, but we're actually connecting to the IP address, if you remember, for this target machine in Exoscale. So we've successfully completed a migration of the source machine from ESX to a target machine in Exoscale, and that's the migration finished. You'd obviously want to maybe tidy things up and make sure that network drivers are up to date and so on, but the machine's accessible and successful migration. If you've got any questions, if what I've been showing has been a bit confusing, because I did come across a couple of issues there, took longer to synchronize than I was expecting, but I think an hour and a half would be acceptable for sending about 3 gig of data, or in fact, because of compression, it was about 9.5 gig of data over a 10 meg link. And also the last step there with the SSH, but that's not Carbonite that's causing those issues. That's limited bandwidth and security settings on SSH. But if you've got any questions, you can give me a shout. I'll just stick my email address at the bottom here. So it's aabs@opentext.com, and so I'll spell the company name right. And if you've got any questions, you can give me a shout. and I can, go through it with you in a bit more detail, take some more time over it. Thank you very much for listening. If you've got any questions, I'll hopefully hear from you soon.